Hello friends, this is Rashmi Singh. Welcome to my channel Unraveling Science. Let's have a moment of science please. Every science begins as philosophy and ends as art. Today's topic is carbon and its compound, class 10 chapter 4 part 1. In this video we are going to learn about introduction of carbon, allotropes of carbon, bonding in carbon, versatile nature of carbon, organic and inorganic compounds, saturated and unsaturated carbon compounds on the basis of structure, isomerism and homologous series. So what is carbon? The element carbon is a non-metal with the symbol C. Carbon is versatile element. The percentage of carbon present in Earth's crust in the form of mineral is 0.02 and in atmosphere as carbon dioxide is 0.03%. All living things, plants and animals are made up of carbon based compound. So as you can see in this picture, about 20% of the weight of living organism is carbon. Carbon is the fourth most abundant element in the universe. It occurs in the nature in free as well as in combined state. In free states, it is present in the form of diamond, graphite, and in combined state, carbon dioxide as in the form of carbon dioxide in air, fossil fuels, carbonates like lime, marble, chalk, and organic compounds like wood, wool, cotton, etc. Allotropes of carbon. So allotropy, it is a phenomena in which element exists in two or more different physical states with similar chemical properties. Carbon has three major allotropes: fullerene, diamond and graphite. Diamond. Each atom is bonded to four other atoms of carbon forming three-dimensional structure. It is hardest substance and an insulator. Graphite. Each carbon atom is bonded to three other carbon atoms. It is a good conductor of electricity and used as lubricant. Fullerene. The carbon containing cluster of 60 carbon atoms joined together to form spherical molecule. It is dark solid at room temperature. Bonding in carbon. Atomic number of carbon is 6. So its electronic configuration will be 2 and 4. So as you can see in this picture, carbon is tetravalent. It has 4 electrons in the outer shell. It does not form an ionic bond by either losing or gaining electrons. It is difficult to lose 4 extra electrons and would require a large amount of energy to remove these 4 electrons. So carbon can only form bond by sharing its electron with the electrons of either carbon atoms or other elements and attain noble gas configuration. So the bond formed by sharing of electrons between the same or different element is called covalent bond. Atoms of other elements like hydrogen, oxygen, nitrogen, chlorine also form bonds by sharing of electrons. As you can see here, hydrogen has 1 electron in the outermost orbit. So a single covalent bond is formed by sharing of 1 electrons by both the hydrogen atoms. Oxygen. It has atomic number 8, electronic configuration is 2s6. So it requires 2 more extra electrons to complete its orbit, outermost orbit. So 2 electrons are required by both the atoms. So it shares 2 pairs of electrons and thus form double bond. Similarly, nitrogen with atomic number 7, electronic configuration 2 and 5. It requires 3 electrons to complete its orbit. So it shares 3 electrons between 2 nitrogen atoms and thus forming triple bond between them. Versatile nature of carbon. Carbon is called versatile because it can form millions of compounds. It is because of two main properties. First is catenation. Carbon atoms have a unique ability to form bonds with other carbon atoms to form long chain. This property is known as catenation and it gives rise to large number of carbon compounds. Second is tetravalency. Since we know that carbon has 4 valence electrons, hence it's called tetravalent, and one carbon atom can bond with other 4 carbon atoms or with oxygen, nitrogen, etc. Organic and inorganic compounds. Compounds of carbon with other elements are called organic compound. Most organic compounds contain carbon and hydrogen and can also contain oxygen, nitrogen, halogens, etc. So as you can see in the picture, carbon dioxide is an organic compound because it contains carbon. Compounds that do not contain carbons are called inorganic compounds, like salt, water, oxygen. Saturated and unsaturated carbon compounds. Hydrocarbons. A compound made up of carbon and hydrogen are known as hydrocarbons. So they are of two types, unsaturated and saturated hydrocarbons. Saturated hydrocarbons. Hydrocarbons in which carbon atoms are connected only by single bonds are called saturated. They are also known as alkanes. General formula for alkane is CnH2n plus 2, where N is the number of carbon atoms. So as you can see in this picture, if carbon atom is 1, N is 1, then hydrogen atom will be 4, forming methane. Similarly, if carbon atom is 2, hydrogen will be 6, forming ethane, and if carbon atom is 3, it forms propane. Unsaturated hydrocarbons. They are of two types, alkenes. Compounds which have double bond between carbon atoms are called alkenes. General formula is CnH2n. So if carbon atom is 2, H will be 4, forming ethene. Carbon atom is 3, H will be 6, forming propene. Carbon is 4, H will be 8, forming butene. Alkynes. Compounds having triple bonds between the two carbon atoms are called alkynes. General formula is CnH2n minus 2. So if carbon atom is 2, H will be 2, forming ethyne. If carbon is 3, H will be 4, forming propyne. Carbon is 4, H will be 6, forming butane. Carbon compounds on the basis of structure. First is straight or unbranched chain, as you can see in this picture. Second is branched chain, as you can see here, branched chain. Third is cyclic chains, like the chains of benzene. Isomerism. Compounds having same molecular formula but different structural formulas and properties are known as isomers, and the phenomena is known as isomerism. For example, butane, which has 4 carbon atoms, can form butane and isobutane with different structures. Similarly, pentane form 3 types of isomers, neopentane and isopentane. Homologous series. A homologous series is a collection of compounds with the same general formula that differ only in carbon chain length. Compounds in the homologous series often have a fixed functional group, resulting in the chemical and physical properties that are comparable. So as you can see in this picture, alkane, alkyne, alcohol, they all differ from each other by CH2 units. Nomenclature of carbon compounds is coming up in my next video, so stay tuned. Thanks for watching. Please do like, share and subscribe.